August and come and stay. We can either camp in his house or just come and stay for a few days.
Yeah. Go for a swim.
Chamber of Commerce today. Come to the sunny beach. What's the name of this place?
Staff.
Clack something.
Clacks.
But look, Lewisian gneiss. But just a second ago you were walking up a slope of sandstone, so the contact is just here, and the contact is just all around here, and our stop's going to be on the contact.
I think one knows your biotite and apple bowls and things, and then the quartz and feldspar segregated. Did you ever get an answer about the mechanism behind the segregation?
Here on Torridonian sandstone, if we can examine it here, you see all this. This is layers of Torridonian sandstone. But then the headland over there, it's Lewisian, but there's a whole load of conglomerate there, which is Torridonian. That's a paleo surface. That's a whole scree sort of debris slope of Torridonian. Can you see there, which is on the Lewisian. But then here, it's not quite as big as the hotel, but this lump here, this is the boulder. But it's at least the size of that house. This is the boulder, and this is made from Lewisian gneiss. But when you actually come down to the beach, which we will, and you examine closely, you will see that there are veins of mudstone that come right up through it everywhere. And we'll go and examine it, and it's hard to see from here. It's easy to see when it's wet actually. But you will notice that all these veins of mudstone, and what the interpretation is, that this whole chunk actually fell down this paleo canyon, and you can see part of the canyon walls here. Here's the scree slope on it, but it fell from higher up this canyon 1.2 billion years ago, smacked into the mud at the bottom, and the cracks injected this through. And as I say, there's a National Geographic article all about this published about 3 years ago, which I've got a link to in the handout, so you should look that up.
Oh yeah. And the boulder on the other side of that cleft as well? Is it just cut?
No, I think the boulder is just this piece here. This piece here, but you know, the fence goes up over the top of the boulder, so the boulder goes inland a bit. Yeah. And as I said to you in the coach, the amazing story of the students who were here, and you know, they always came here, and it's marked on the geological map as a fault here, and actually that surface is quite a flat surface, so maybe there is a fault through here as well, after all this boulder had fallen and some hundreds of millions of years after. But it was just marked as a faulted contact, but then there's a whole load of the Torridonian not faulted. That's just an unconformity. That's just a conglomerate, billion-year-old conglomerate sitting on top of Lewisian. Yes. And it's as if it slipped down yesterday, but it slipped down 1 billion years ago, which is amazing, isn't it? So what we'll do is we'll go down onto the beach and let's go and have a look at some of these sort of mud dikes coming through the boulder.
So we're at one of the largest boulders, and this is Lewisian gneiss, 3 billion years old, and there was a meteor impact not far from here, and this is an isolated boulder that's pretty large, and it has injectites of brown mud. So what must have happened, something caused this boulder to fall down a slope, this Lewisian gneiss boulder, and land in brown mudstone that injected into the fractures. And so one can speculate what would do that.
So this is 3
billion years old.
3 billion years old, maybe 3.2.
But the fracturing is probably just
in the fracture.
So all this cross-hatching fractures?
Yeah, they're just from the impact of the boulder hitting the ground.
Yeah.
Is that it? That's just this
Right there by where Doug's sand was.
Here.
Yeah, that's where it goes up to the right and up to the left.
So the material that's injecting is crushed gneiss is
No,
injected
it's
in there?
mud that it lays it on its set, he said.
Oh, wow.
Right, if you just, where you are right now, so where you are right now, look.
Well, he
Look,
came down
can you
the
see?
Richardson way.
Here's the mud. Look, it's forced its way in. This brown is the mud.
Okay.
It's the mud. And it's got black lichen on it, unfortunately, in places. But look, this is the mud.
Right.
See the mud? And it comes all up in that crack. It's always in this crack. Here, this is all mud. This triangle here.
Yep.
All
All
mud.
mudstone. Squidging up that crack.
Wow.
So there's a good bit of mud just by your ankle
Oh
there.
yeah.
You can see it's brown.
Yeah, right there. And then piece
Yeah.
coming off in that direction.
Yeah. So you can really see that that's the mud. You see the brown colour. Yeah. Oh, that's a nice one. Yeah, this is tough. Now the fracturing here, he recognises how it's this primary fact. Well, I'll let you use your own words.
Primary stress fractures. The impact or whatever the situation was exceeded the tensile strength of the rock, and these are the kind of primary stress fractures that you see all over the world.
Absolutely.
Crisscrossing like that.
Yep.
It looks like some little samples have been taken from it there. Maybe I don't know. Maybe they haven't. These little holes here.
The fracturing would have occurred before the mud. It would have occurred at the time.
At the same time.
Simultaneously.
Yeah. If you look at it,
I'm here looking at the Lewisian gneiss in the Highlands of Scotland. And these are 3.2 billion year old rocks, some of the oldest rocks on Earth.
Yes.
well, anyway, we will enjoy getting pictures of this for 5-10 more minutes or so, and then we'll wander back and have our lunch. This is a clear, this is a true That's yeah, this stuff, a billion years ago, down the road. So this, in fact. That's this slope here is the canyon wall. There was a massive canyon. It might have been. So here we are looking at the classic unconformity here on the shores of Loch Assynt. And at the base here you've got the 3 billion year old Lewisian gneiss, some of the oldest rocks anywhere on the planet, and you have a 2 billion year time gap here. That's half of Earth history just missing, and on top of it is completely unmetamorphosed 1 billion year old Torridonian sandstones. And these sandstones formed from the erosion of a mountain chain that would have existed back then 1 billion years ago and had been deposited by rivers. And here we can see this cycling of the river sequences as we go up. But what an extraordinary sight. All this kind of flooding and flash flooding, so you can see study the Torridonian, but the main thing is look at the unconformity, and it's just really special just to be able to touch it. $2 billion years, just half of Earth's history just missing. Just 2 billion years.
That's trying to get fresh samples from photography.
It's rather wet to step across, but there's some dry bits as you can see.
There's some conglomerates in here.
So this is Torridonian conglomerates.
Yeah.
They're 1 billion years old.
Yeah. Climate change, climate change, climate change, climate change. Excuse me.
It's got the class of the Lewisian, I think.
Yes,
which
so
is
it's
to be
reworking
expected.
so it's conglomeratic, so it's pretty proximal, and the reddishness, the brownishness, oxidized, so probably wet and then dry, wet and dry, cyclic, many repetitions. And what people like to do, of course, is they like to map the thicknesses, and are the thicknesses getting thicker or thinner?
Yeah.
Where are you on the sea level? So we'd have to look at that. It looks like they're getting thinner up there. This is a big one.
Yeah.
This is less big, and when you get up there, it's thinner. So here is the base of the Torridonian, right? And here is, oops, excuse me, this is the Lewisian gneiss, and this rough unconformable surface is a 2 billion year gap.
2 billion years.
Where has the time gone? Hard rock. I have to look at it. It's possible what often happens is somebody gets the idea that student may have read about injectites. There are a couple papers on them.
Okay.
Something might have planted this.
Planted the seed in their head.
So this is called the Cambrian sandwich, and if we look behind us, the knobby, bumpy Lewisian gneiss with the green grass growing on it. At the top of it, there is an up and down unconformity, and the layered reddish brown sandstone is the Cambrian sandstone. And on top of that sandstone, there's a very sharp contact. That is a thrust, and the lumpy, bumpy Lewisian gneiss is thrust over the Cambrian sandstone, which is unconformably overlying the Lewisian gneiss. So it's Lewisian gneiss at the base, unconformity up depositionally to the Cambrian, and then a Lewisian gneiss thrust over top.
Be for sale there, but they might only have like 2 or 3 in stock, so it might be first come, first serve. I opened the last one before. This is just what a riot of colour that is. It's just, and then the complexity in these cross sections. But we're up here, Loch Glencool, and what we're seeing, this Kyle School Bridge. Yeah, we're here, and we're looking across. That here is the Lewisian, the Cambrian sitting unconformably on it. There's the thrust fault with Lewisian over it, but behind you've got more Cambrian, and then you've got the Moyne thrust bringing the Moyne metamorphic rock over the top. So that far away mountain back there, that's the Moyne thrust at the base of that. So that's the Moyne supergroup rock coming in over that, and. But yeah, I just look at all of this, and this is interpreted as being eroded off, that greyer colour, but it is vastly complicated. So, you know, the simple story is just this terrain has slid over the top of the other terrain, but the reality of the situation is that actually many parallel thrust faults, and where we stopped at Knock and Crag yesterday, it was nice and simple to see it because it's just the one fault. It's just over, job done, easy. But actually inside these 2 splays, crazy. Look at the number of thrust faults, and actually the Benmore thrust isn't the same as the Sole thrust. That's the Benmore thrust, that's the Sole thrust, and we're on the Benmore thrust. So they're just parallel to each other, and it's a sort of a zone of thrusting here, if you like, whereas here it's just in a single thrust fault. Going between my legs is a Scourie Dyke. Can you see that everything's blacker here? Yeah. So this is the Lewisian gneiss, which is 3 billion or up to 3.2 billion. This is Scourie Dikes, 2.4 billion, and this is back in the Lewisian. So this is a sort of normal sized dike. It's quite wide, but quite a big dike. And this sort of area is cut by several of them. But if we come up here, and I kind of already given the answer away a bit when I was talking to the microphone on the coach. But if we come up here, where's the dike?
Well, everywhere.
Yeah.
It's a big one.
If we come up here, the whole thing is the dike. The whole width of the beach is the dike. So all of this black is the dike.
Yep.
And because the dike is actually softer than the gneiss, it's eroded it out, and this whole thing is the dike. So really that's the stop in the story. And if you go down onto the beach there, you can collect pebbles of the gneiss, you can collect pebbles of the dike, but also and I haven't really found it, but I read in the guidebook that within this gneiss there are these pods of hornblendites, but I haven't really identified them, and it's all covered in lichen, and I haven't really seen them, but I've read about them here as well. So my recommendation is to go down onto the beach, and actually one time I actually found a pebble. Actually, one of my customers found a massive one like that and took it, and actually Abby and I gave it to Abby and I because he realised he couldn't fly home with it. And it's actually the contact, it's actually the Lewisian gneiss half of it, and the other half of it's the dike. So we use that as the doorstop for our office, but it was actually found here. Yeah, Charles, I'm really...
So we're looking at the Lewisian gneiss, which is a granulite facies, tonalite. This is the oldest part of the Lewisian gneiss, perhaps up to 3.2 billion years. And in this northernmost area where we are, it's got many Scourie Dikes. Now the Scurry Dikes are 2.4 million. They're later intrusion. They trend northwest-southeast, and they fracture, they fill in and intrude. But this dike is famous because if you look to where some of our fellow geologists are standing, that's the gneiss in the face, and the black, that's the contact, and this whole beach, which is weathered out 40 meters wide, it's the largest accessible Scurry Dyke. So it's really quite an amazing place. And if you follow out over, let's look back this way, towards the other Rockfall face, that's the other contact. And because the Scurry Dyke weathers and dissolves chemically more easily than the gneiss, there's a lower relief, creating this whole wide beach.
Boy, the geologists have been everywhere taking tours.
Of the actual dike.
Yeah.
So, and then this is a larger chunk that I found on the beach.
Okay.
And then these are dike material, but they've been polished because they've been tumbled. Yeah. It's just all the same material. That I don't know.
Isn't that great?
Yeah, it's beautiful. It could be. It could be.
So these are the Scourie Dikes. It's a billion-year-old lava injected into a 2 billion-year-old gneiss.
If you all stand on this side, I will go over and point out the different units, and then you can all come over and have a look. But if I...
One moment.
Okay. So if you stay on that side, Yeah, the drills cut through to make the road cuts. Yeah.
Okay, James, here's a piece for your garden.
Yeah.
Just a little bit too big, unfortunately.
We're ready.
Who wants a picture? Anybody want a picture? We'll take a picture of you with the rocks in the background.
Sure. Well, my camera's just about out.
Mine too, but it doesn't matter if it's out if we get the picture before it goes. So if you stand right here, I'll get you in the foreground and you'll have an incredible background. People will be. That's
hydrothermal deposits then, and that's where all the sulfide ores are.
well, in the matrix, this is, I think this, you got to confirm this, I think this is the host rock.
Yeah.
And then this injects in.
Mm-hmm.
And then this stuff injects into this. So this is one, this
That's
is two, this
interesting,
is
because
three.
usually, you know, this is a basaltic injection. This is a sialic injection. You don't usually see those two together like that at all.
Which was the host rock?
So right here,
I thought the pegmatite
like
was the
this.
host rock, but
no, the pegmatite is the number 3, John, I think.
been less on the motorcycle than you will on the car. You're spending all your time looking at the road.
I know, yeah.
Yeah.
So this is amphibolite. Nice piece of quartz. As we move along here, we have amphibolite. Dark. And then back to the old 3 billion year granite. Well, it's a granite gneiss cut by another dike.
Look at that. These are pegmatites here, all cut by dikes. Look at the size of those crystals. You need to start looking for gold.
It just goes on and on and on.
So look here at the contact between the intrusive dike and the pegmatite of the older billion-year-old rocks.
I could probably pull something. Probably me right now. Duncan Dyer's you saw that one up there, and then you realized,
But I mean,